Today we're going to talk about Pythagorean theorem. This is super important, and you're going to use it for this section, but you're also going to use it the entire year next year. So don't make me teach you this again. Learn it now so you can learn it and you've got it under your belt. It's in your BK, it's in your background knowledge, and you understand altogether what Pythagorean theorem is. Remember, Pythagorean theorem is all about measurements and side angles in right triangles. Right, Kiki? Right? Okay, so this is 11.6. Do you understand the Pythagorean theorem? So the first thing we need to do before we even begin to talk about Pythagorean theorem is talk about what is a right angle, what is a right triangle. So a right angle you've seen before has this little box in the middle. That little box tells us that that angle is 90 degrees. When we connect the two ends, like so, that becomes a right triangle. Okay, so this is a right triangle. So anytime you use the Pythagorean theorem, you must have a right triangle. And a right triangle is a triangle with exactly one right angle. Now, you'll learn a lot of this next year, but we're going to kind of preface this. A theorem is a statement that has been proved to always be true. So the Pythagorean theorem is a theorem that has been proved that it will be true every single time. The Pythagorean theorem is a squared plus b squared equals c squared. Here is your picture depicting the Pythagorean theorem. All right, so we're going to look at example number 1, and we're going to figure out how to work with this problem using the Pythagorean theorem. So I'm going to make this just a little bit bigger. And it says find the lengths of the side B in this triangle. So the first thing we need to know is we need to know that Pythagorean theorem is a squared plus b squared is equal to c squared. So the first thing we need to know when we work with triangles like this is that when we label the sides, this is side C and B and A. This is just a replica of this triangle right here. The little b, you notice, is across from the angle B. So the little a is going to be across from the A, and the little c is going to be across from the big C. Now, the one thing that you will know in Pythagorean theorem is the c is always the hypotenuse. Okay, remember the hypotenuse is the side across from the right angle. So this is your right angle right here. C is always the side across from that right angle. Okay, so let's go ahead and begin to solve this problem. A right here is 12. 12 squared plus B is B. So we're going to leave it b squared equals c squared. C is 15. So we'll write 15 squared. Hopefully you have your calculator available and you can find out that 12 squared is 144 plus b squared is equal to 15 squared. And we'll just find out what 15 squared is. I think it's 225. 225. Now, I pulled this up because I want you to see this real quick. I pulled this, like I said, up here because this is going to be part of how we solve this equation. So right here, we're still working. We have 144 plus b squared is equal to 225. So we know solving equations, we look at the side with the variable and we move what's not touching the variable. So I'm going to subtract 144 from both sides. That leaves me with b squared is equal to 225 minus 144 is 81. Now, this problem says right here, or this little formula says that I brought over, to solve an equation in the form of x squared equals c, you take the square root of both sides. I want to kind of shove two lessons into one here. So hear what I'm saying when I say this. Squaring and square rooting are opposites. So you know when I say, what's the opposite of multiplying by 2? And you all say, dividing by 2. So when I say, what's the opposite of a square? And you're all going to say, a square root. Okay, so let's practice. What's the opposite of squaring b? Square rooting b. If we square root b squared, we also have to square root 81. So the answer is then b is equal to 9. Now we know it's plus and minus 9 because we know a square root, we've talked about this before, can be plus and minus. But we are going to assume the positive right now, but please understand that it can be plus or minus. Now, the reason we're assuming the positive is because we're talking about triangles. You can't have a triangle with a negative side measure. So just remember that, and especially as you leave this year of algebra behind and you go into geometry next year, you're only going to be dealing with the positive values. However, that is not going to be forever. You will, when you get to algebra 2, you're going to bring those negatives back in. So remember, the square root of 81 is positive plus or minus 9. All right, so let's do example number 2, still using Pythagorean theorem. Once again, we have a squared plus b squared equals c squared. I actually think this one is easier than your last one because you're looking for the c squared. So here we go. A is across from the A. Now, because this is addition, it doesn't really matter if the A is the A number and the B is the B number, because remember, addition is commutative. But in this case, A, what is across from the A? Well, if we look at our picture, well, there's that 10. All right, so it's 10 squared plus B. What's across from my B? 20. So 10 squared plus 20 squared is equal to c squared. All right, well, 10 squared is 100, and 20 squared, is 400, is equal to c squared. So 100 plus 400 is 500, is equal to c squared. Now, once again, we just need to say, all right, what's the opposite of a square? And we all say a square root. Now, this doesn't give us a nice, pretty little answer, so we have to use our calculator. So we're going to square root both sides because the opposite of a square is a square root. And you can either simplify this, which is what I want you to do right now, or you could use your calculator, because later on you're going to need to use your calculator, especially in geometry, if you're finding a side length. You can't go into the hardware store and say, I need a piece of rope that's the square root of 500 inches long. He's going to look at you like you're crazy. But for right now, we like this. So I'm going to rationalize 500. I'm not going to rationalize. I'm going to break it down. 500 is, let's see, 5 times 100. Right? I know 100 is 10 times 10. So it takes 2 to bring one out. I got 2 10s right there. So I'm going to bring out a 10 square root of 5. So that becomes 10 square root of 5. 10 square root of 5 is equal to c, because the square and the square root cancel out, goes away. All right? And if you needed to put it in a decimal approximation, you could type it into your calculator and you would have to round, but it's approximately 22.36 is equal to c. Okay? All right. Remember, plus or minus, but in this case, it's only the positive case because it's a physical item. Now, in example number 3, it doesn't look like anything we've done so far. You say, oh, you said Pythagorean theorem, and we're going to use Pythagorean theorem, and I don't understand this. Now you've got me graphing points, and what does this mean, and why are we graphing points? Use Pythagorean theorem to find the distance between P1 and P2. So the first thing I'm going to do is I'm going to plot P1. P1 is at -3, 1. So -3, 1. There's my dot right there. It's kind of sort of right in the right spot. And P2. P2 is at 5, 4. So that's right there in that spot. Now it says find the distance between these 2 points. Now we'll have something called the distance formula that you're going to see in just a second, but I want you to understand that the distance formula was derived by using right triangles. And I'm going to show you why. So we'll call this P1 and this was called P2. So if we look at this as a triangle, to move from this P1 over to P2, I'm going to go over this many. Now, if we count how far over that is, that would be 1, 2, let me put little dots. 1, 2, 3, 4, 5, 6, 7, 8 units across. So this is 8 units. And then to get up to that dot, I'm going to move 1, 2, 3 units. What do I have right here? Those two are perpendicular. If we took the slope of both of those lines, we would find out their slopes are negative reciprocals. We talked about that earlier this year. So now all I have to do is look at this as a right triangle with the sides 8 and 3. So I'm going to use Pythagorean's theorem, a squared plus b squared is equal to c squared. My c is what I'm looking for. So a can be either one we want. I'll say 3 squared plus 8 squared is equal to c squared. That's 9 plus 64, is equal to c squared. I don't know what I did right there. And then that becomes 73 is equal to c squared. Okay, so then I could just say, find the square root of that, square root both sides. The opposite of a square is a square root. And 73 won't break down. So it's plus or minus 73, but in geometry, we know distance is positive. So c is equal to the square root of 73. Okay, and if we wanted to approximate it, we could put it in our calculator. Square root of 73 is about 8.5, about 8.5 units. Okay. So I said earlier I was going to show you the distance formula today, and I am. There it is. There's the distance formula. This is a great formula. You are going to use this and use this and use this and use this when you get into geometry right at the beginning. This basically is using the Pythagorean theorem. And we're going to kind of prove that more when we get into geometry. And I don't want to overwhelm you right now, and especially since we're doing this via computer learning. But the distance formula is this right here. The distance between any 2 points, x1, y1, and x2, y2, is given by the formula d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to use the distance formula for these 2 points. Now, I like to mark my points. This is x1, y1, x2, y2. That just means the x in the first ordered pair, the y in the first ordered pair, the x in the second ordered pair, and the y in the second ordered pair. So I'm going to plug my distance formula in. D is equal to the square root of x2 is 5 minus x1 is 2 squared plus y2 is 1 minus y1 is 1 squared. All right, so I have my nice setup. So that's d is equal to the square root of 3 squared plus 1 minus 1 is 0 squared. Well, 0 squared is 0. Oh, look at this, friends. D is equal to the square root. 3 squared is 9. We know the square root of 9. The distance is equal to the square root of 9. What's the square root of 9? 3. So the distance between these 2 points using the distance formula is 3 units. Whenever we're not told feet, inches, yards, we just use the word unit. So it's 3 units. Okay. All right, so last example for today that I'm going to have you work is example number 5. Find the distance between these points. D is equal to the square root. Once again, your distance formula is x2 minus x1 squared plus y2 minus y1 squared. All right, so let's use that and fill things in. D is equal to the square root. All right, x2 is the x of the second order pair, which is 6, minus x1, which is negative 2. Oh, look right there. That's minus a negative. Okay, keep it the way it is. Plus y2, excuse me, y2 is negative 5 minus negative 9 squared. Now I'm going to remember that I have sign numbers here. A minus minus makes a big old plus. A minus minus makes a big old plus. So I have D is equal to 6 plus 2 is 8 squared, plus negative 5 and 9 is 4 squared. That is 64 plus 16. That's the square root of 80. So D is equal to the square root of 80. Now, 80 doesn't have a nice little easy number. It can bust out into, like 81 would be 9, but 80 is nothing like that. So I could break it down up here and say 8 times 10. 8 is 4 times 2. 10 is 2 times 5. 8 is 2 times 2, bring down the 2, bring down the 2, bring down the 5. All right, it takes 2 to bring 1 out. I'm going to bring out 1, 2. It takes 2 to bring 1 out. I'm going to bring out another 2. 2 times 2 is 4 square roots. That 5 is left over. So the distance between those 2 points is 4 square roots of 5. If you wanted to put it in your calculator, it would be almost 9, because we know the square root of 80 is very, very close to the square root of 81, and the square root of 81 is 9. Now, the next couple things I'm going to show you, and it's not something I am giving to you today. And there's a reason for this. I just think it's too much in one section. And I feel like there's more important things I need to get to for you for this next week and a half or 2 weeks that is of more importance than this one. We're going to hit the midpoint formula again when you come into geometry. So don't worry about it. It's not like you're not going to get it. It's actually going to be, I can't remember if it's the first or second unit in geometry, but it will use this formula right here. And to be honest, this formula is actually kind of, again, a derivative of Pythagorean's theorem. But if you are really, really, really interested, go to Khan Academy and you can just look up lessons on midpoint formula. You'll see me abbreviate it like that. If you want to look up lessons on Khan Academy of midpoint formula. If your curiosity is getting the best of you, go to Khan Academy or ask me on Zoom. You can ask me on Zoom. I'll answer those questions. It's just a little too much right now, so I won't put anything for midpoint formula on the test for this, and we will really, really hit into it hard when you come up into geometry. Okay, so that's it for Pythagorean theorem. You are going to be doing, I think I put on your work 1 through 27 odd, but the other day I did something totally different in the last class, and they were like, you didn't do that on the sheet. So I don't know. Work some problems so you feel comfortable with this. I think 1 through 27 odd sounds good, but no midpoint. So if you see a midpoint problem on there and you're like, oh, she said we didn't have to do midpoint, then don't do it and skip it. Okay? All right, y'all. Have a great one.